Okay, we're going to talk about the golden ratio. This is the number that's called the golden ratio. It's approximately to this number over here. Now, since the golden ratio is a constant, it's usually represented by the Greek letter. Greek letters here, and this is footnote number 30. Footnote number 30 says how to pronounce it. This symbol here is pronounced var phi. This one over here is just phi. All right? Let's talk about how to get it. So, it says it's a solution to this one over here. This is quadratic. We'll have two solutions. Now, clearly, the solution that we're looking at is one of those two solutions, and it's a positive solution of that equation. Let's go through that. So we're going to find a solution to this equation over here. And I'm going to use the letter x instead. So x squared equals x plus 1. The reason I use x is easier for me to write that symbol than it is to write the other one. So let's write this out in standard form. So what do you get? X squared minus x minus 1 equals 0. I'm going to use the quadratic formula in this. That says x equals, well, the opposite of the coefficient on the linear term, plus or minus the coefficient of the linear term squared, which is 1, minus 4 times a, which is 1, times c, which is minus 1. So it's going to be plus, over twice the coefficient on the square term. And what do you get there? X equals 1 plus or minus the root of 5 over 2. You can also just by completing the square, and that's done over here. It's going to lead to the same answers, which is 1 plus or minus root 5, all divided by 2. Now again, we're just picking the positive one, and we're going to call this the golden ratio. All right, let's take a look at a picture. This is a picture of the graph. Let's write this down. This is the graph of y equals x squared minus x minus 1. And it has two roots. This is the root that we're concerned about. And this is the golden ratio over here. And this is where x equals 1 plus root 5 over 2. All right? So I also put down something that, I don't really see this being a very memorable number, although some people do attach memory to that. I don't. I also want to point out there's a continued fraction form of this, which is remarkable. And the continued fraction form of this one is right over here. It's just a bunch of ones. Right now, if you've taken I'm going to read that footnote to you. If you've taken a rigorous course of algebra in high school, you might have seen them compute continued fractions for both rational and irrational numbers. All right, and that would be a rigorous algebra course in high school. All right, and they did it for most likely, certainly for rational numbers, but you can also do it for irrational numbers. All right, thank you.